We'll proceed in surface area calculation, vector algebra calculus. Vector algebra calculus. This is what the topic that we are pursuing. Vector algebra and calculus. Vector is considered as the most advanced technology as far as mathematics is concerned because it has direction and it has magnitude both. If I talk about algebra, then algebra is nothing but variation representation of numeric only. So net result of algebra is numeric only. There is no direction attached to the algebra. But vector has the direction. If it has the direction, then vector components, vectors are represented through orthogonal components. So like I plus j, where the x-axis component is 1 and y-axis component is 1. If that is the case, then this is called numerical vector. Everything is, if I have numerical in mathematics, then if I add direction to it, it becomes numerical vector. If I have algebra and if I add direction to it, it becomes algebraic vector, also called vector field, sometimes also called parameterized vector. Simple, right? If I have numeric, if I have 2, item is 2. A person is running at a speed of 2 km per hour. Person is running at a speed of 2 km per hour. Means person is running along x-axis. What is your x-axis? X-axis is east side. East side is my x-axis. Then y-axis is north side. Okay, minus x-axis is west side and minus y-axis is south side. Okay, my idea is not to say that west is bad and south is bad. I denote west and south as minus. All are equal to each other. This is a kind of easy way. If I see the globe, then right side anyway goes like east only. So if that is the case, person is running. If I take a globe or map and person is like there is a explorer, and his name is, I believe, James Cook, British explorer, British Navy naval officer, and I believe 1769, James Cook made 3 explorations, very historical exploration, and in one of them he traced New Zealand. Now, which direction James Cook he started his journey? Then from England he started journey in kind of minus I or minus 10I minus j. Means he tried westward and little bit southward, or minus I minus j means southwest in 45 degree from the west side. He started his journey and he went till the southern tip of Southern America. From there, because America is completely closed, right? So in that sense, from there, then he started. So once he reached the southern tip of Southern America, from there, then he entered Pacific Ocean, and from there he started his journey. From there he started his journey minus I j, or rather I would say minus 2I j plus j. Okay, so this is the way, rather than saying that James Cook started his journey in west, south, little bit north, and this and vector is there, then why you are worrying about the direction? Very minute direction the vector would take care. Okay, I don't want this. For first, for some time, he was I minus j. Then he changed in direction. Then he came to southern tip of South America. Then he changed his direction, and then he changed his direction. Then again he changed his direction. Then he reached New Zealand. So vector form I have to say 20 times. This direction, this direction, this direction. I minus I minus I minus I. Can you Can you talk in single line? Okay, it is minus sine x I plus then e to the power x minus x j. What is this? This is algebraic vector. First component, that is ith component, is algebra, that is x, and second component, that is j, it is again algebra. So what is algebra here is based upon, if you consider England as the origin, then minus x he is going and minus y he is going. Keep changing x and y, and at that moment you will get the exact vector direction where is he. Rather than saying at this point he was in this vector direction, at this point he was in this vector direction, at this point he was in this vector direction, like that you can, in a complex algebraic form, x component complex algebraic form, y component complex algebraic form. Now someone can demonstrate this is called vector algebra, algebraic vector, and it is considered as complete one. Okay, we are in discussion for the what is the surface area of a sphere. The first way, that is called algebraic way or primitive way in calculus, that we have seen, where that through that we have calculated the surface area of a vector. Okay, now we will see the modern way to calculate the surface area of a vector. So that is a chance. So I have a surface area of a sphere. I really have a sphere. Okay, this is a sphere. I believe leaf is already still there. So this is a kind of a raw sphere. Okay, if this is a sphere, then what is the surface area of this sphere? So that is under question mark. What is the surface area of this sphere? So when we are talking about the vector, this sphere is centered at the origin. If this is x-axis, this is z-axis, this is y-axis. In that case, this point is origin. Now this sphere is centered at the origin. The center of this sphere is kept at the origin. So this is xy plane, and top is top hemisphere and bottom is bottom hemisphere. So this is how it is. Now from center, let's consider there is a point here P. There is any point here P. P. From center, I can take a line. From center, I can draw a line, and that line is called a vector. Vector has a direction. So from origin, from to point P, if I draw a line, that will show a direction. So that is a vector. If this point P is x comma y comma j, then vector equation is x minus 0I plus y minus 0j plus z minus 0k. Xi plus yj plus zk is the vector equation, of this vector xi plus yj plus zk. Okay, now understood. If I talk about primitive way, then through primitive way, I have to calculate the vector. I have to calculate the vector along the surface. How vector along the surface? Anyway, what we have seen till now, if this is point P here, I cut vertically in xz plane, I cut vertically in yz plane. This is what we have seen. If I cut it vertically in xz plane, then it will come as a circle where the point P is here. If I cut in cut kind of in yz plane, probably that circle will be smaller. The right hand side I have taken, circle will be smaller. Okay, and point will be somewhere here, here, here. Now in xz plane, if I talk about primitive plane, case, I have already talked in highly detail in the last video. So here in primitive way, we have to calculate the tangential vector, or curve vector along the curve at any moment. What is the vector? If I have a line, then what is the vector along the line? If I have a curve, then what is the vector along a curve? There we saw, if I have a position vector and if I differentiate it, what the next vector I am getting, that vector is along the curve. If I get the vector along the curve, if I get the vector along the curve, then that vector length into x, provided that vector has x component as 1. If x component is 1, and then if I calculate the magnitude of that curve vector and multiply by x, that gives me vector length at that point. Okay, if I'm sorry. So I'll reiterate it. So this is origin, this is x-axis. This is origin and this is x-axis. Now we are trying to calculate the curve length. At any point, at any at any point, what is the curve vector? Curve vector, if I get, I make that x component is 1. Now, to get the length from x equal to origin to any point x, then I multiply it by x, then I get the net vector length or curve length. These are abstract term. This is not the real term. In that case, vector length into x, I get the net vector length. But vector length is a dependent variable, and x I'm multiplying it x axis, that is independent variable. Dependent variable, independent variable multiplication will go in the integral calculus, and it resolves into the magnitude of that into dx, integration 0 to x. This is what we saw in the previous example. Okay, that is primitive calculus. You calculate that in, so you get the curve vector in xz plane, get the curve vector in yz plane, do the cross product. If you do cross product, you get the surface vector. Surface vector dx, dy, and then the x from where to where, y from where to where, you get the surface area. What about the new algebra? This is what the point of discussion now. New way in algebra. What is that? So new way in algebra is that if I consider take any point P here, it is centered at the origin, any point P here, then that point is x comma y comma z. Okay. Now I cut that at that position, I cut in xz plane. If I cut this in xz plane, this will resolve in a circle. If it resolves in a circle, then if this is x-axis, then this point here is x comma y comma z. Okay. Now along x-axis, this is any point x. This is any point x. And then if I go in, this is z direction. This is x direction. This is z direction. It is at any y, fixed y. Now at any x, if I see here that is x comma y comma z. Now from x I go delta x. This proof is not available anywhere else. If I go x plus delta x, then if I go up, then there is a new point. One point is called P, then other point is P1. P1 is x plus delta x comma y comma new z. So z is function over x and y, fxy. So it is x comma y comma fxy. New point, that is P1, is x plus delta x comma y plus fx plus delta x comma y. Now, if these are the 2 points, if I connect these 2 points, then it forms a vector. Consider this vector is P1 vector, P point and P1 point, P1 vector. If this is P1 vector, the vector is x plus delta x minus xi plus y minus yj plus fx function x plus delta x comma y minus fxy k. This is P1 vector. If this is P1 vector, we know, right? This is P1 vector. Okay. If this is P1 vector, then what about YZ plane? If this is YZ plane, then again there is a P here, this side. Here, if this is YZ vector, if I just little bit rotate, then again this is origin and this is Y at any x. This point is x comma y comma z. If I move little bit in y, the next point is x comma y plus delta y comma new z. New z is f small f function over x comma y plus delta y. If this point is P, then this point is P2. Now there is another vector. If I connect these 2 points, there is another vector called PP2 in YZ plane. PP2 is x minus xi plus y plus delta y minus y j plus plus now fx comma y plus delta y minus fx y k. Now if I have if now if I take, okay, how we calculated the curve length through the new method. If you remember how we calculated the curve length, if this is the curve and this is the 2 point that is p1, then that vector is nothing but delta xi plus f x plus delta x in 2D, fx plus delta x minus fx j. That is the vector. Okay, if this is the vector, then I can divide this vector by delta x and multiply it by delta x. No one stops me. Okay, if I do like that, then it becomes I plus fx plus delta x minus fx by delta x j. And right hand side, that term becomes exactly dfx by dx. Fx plus delta x minus fx by delta x becomes dfx by dxj. This is the vector, that is I plus dfx by dxj. This vector, this vector into delta x. Okay, if this vector into delta x, if I try to calculate magnitude of it, this is nothing but I plus dfx by dxj into delta x. If I settle it down, it becomes delta xi plus f plus dfx by dx into delta xj. If I calculate the magnitude of this vector, then it becomes 1 square plus dfx by dx whole square root into delta x. This is the magnitude of vector for delta x duration. If this is the okay, if this is the x and it is delta x, for delta x duration, if I have a vector, this vector is nothing but connecting 2 points, 1 point, 2 point. Someone would say, so this is not the curve vector, because curve vector will be tangential, it is not inside it. Consider delta x is very small. This is the new way. Delta x is very, whatever the way you understand, very less, that is that one. So at then that case, we consider it as it is tangent at that point. In that case, this can be considered as a kind of tangential vector. I don't go with the new way, but this is how it is. Books, this is how it is. If that is the case, for delta x duration, the length of the vector or length of the curve is the magnitude of the vector. That is 1 square plus dfx by dx whole square root into delta x. Okay, if that is the magnitude of a vector for one strip, delta x is infinitesimal small, I took. If I cut it into 1 billion strip, delta x, what will the curve length? Addition of all what we calculated, that will be the curve length. Okay, so whatever comes, that you can watch in the previous video. Now similar thing I am going to take for this sphere. Now this sphere, this sphere, this point is called P point. If this is P point, this is point P, then if this is point P, then at point P I make a small area at point x comma y comma z. I make a small area. That a small area has a small rectangle. It has a width of delta x and height of delta y. Hop. I mean, I'm wrong. Okay, at point P, okay, at point P, at any point P here, if I see this sphere is centered at the origin. If that is the case, the impression of the sphere, actually it is not above this is xy plane. It is not above the xy plane. It is xy plane is going inside it. It is coming as a half of the way. If I see impression of this on this xy plane, this will come as a circle. Now at any x comma y, the point P is x comma y comma z. At any now I take a small region on this. For this small region, if I go and map on the xy plane, that will form a small rectangle. That is x plus delta x. The right, if there is a point called x comma y, then right top corner of that rectangle is x plus delta x comma y plus delta y. Okay, means if I cut this in xz plane and it resolves in a circle, if I cut in xz plane, if I cut in xz plane, oh, if I cut in xz plane, if I cut, it's very difficult. I'm really sweating. Okay, if I cut in xz plane, if I cut it in xz plane at any point P, if this is x-axis, this is x. Okay, if I go in delta x along x-axis, the new point come P1. The vector from P to P1, that is P1 vector that we have seen, that is delta xi plus fx plus delta x comma y minus fxy k. That is the pp1 vector. Similarly, in yz plane, if I go and if I get the vector connecting the 2 points, one point is x comma y comma z, that is p. Another point is p2, where x is any constant in yz plane. The other point is x comma y plus delta y plus fx comma y plus delta y minus fxyk. If that is the case, then the pp2 vector will come as delta y j plus fx comma y plus delta y minus fxyk. So I have these two vectors, pp1 vector and pp2 vector. So if I have at any point I have one vector pp1 that is in xz plane, I have another vector that is pp2 in yz plane. If I take the cross of these two vectors, if I take cross of these two vectors, then it will give me the area that comes under this vector. That is the area. If that is the same area, if I see the xy plane, in the xy plane, the point P is xy, x comma y comma z. That P, if I go down and mark in the xy plane, that point is x comma y comma x comma y in xy plane. Now delta x I moved along x-axis and delta y I moved along y-axis. One is yz plane, one ring I am showing. In xz plane, if I cut it in xz plane, it make a ring like this. If I cut in yz plane, it make a ring like this. If that is true, then in xz plane, from point x I move delta x. If I move delta x, then it will hit another point in xz plane. These 2 points P and P1. One point is xi plus yj plus zk, x comma y comma fxy. Another point is x plus delta x comma y comma fx plus delta x comma y. Similarly, in yz plane, if that point is px comma y comma z, if I move delta y along y-axis, and then I see the another point that is p2, that is x comma y plus delta y comma fx comma y plus delta y. Now pp1 vector, that vector will come as x plus delta x minus xi plus y minus yj plus fx plus delta x comma y minus fxyk. Similarly, P2 vector will come as x minus xi plus y plus delta y minus yj plus fx comma y plus delta y minus fxyk. Now P1 vector and P2 vector we are getting. So one vector is delta xi plus fx plus delta x minus y minus fxy k. One vector is delta yj plus fx comma y plus delta y minus fxy k. If these two are two vectors, that is pp1 vector and pp2 vector. For this pp1 vector and pp2 vector, if I am taking, then for p, the point p, if I see in xy plane, then that is x comma y. The point p1 is x plus delta x comma y. For point p2, that is x comma y plus delta y. Okay, if that is the case, then this forms a rectangle. I take it, this is xy plane. If this is xy plane, this point is P. Then this is P1 on x-axis. If this is y-axis, then this is P2 on x-axis, y-axis. X comma y, x plus delta x comma y, x comma y plus delta y. This forms a rectangle where the top right corner is the x x plus delta x comma y plus delta y. If this is the rectangle on xy plane, small rectangle width is x and height and length is delta x, delta y at point x comma y. If it goes up, if it is goes up and at point P it matches, then there is small surface area it will make. Understandable, right? So if this is xy plane, if there is a point P here, if there is a point P here, if I map it on xy plane, it comes here. That is x comma y. Now in x comma y, in xz plane, along the x axis, I move x plus delta x. In yz plane from y, I moved y plus delta y. If that is the case, then if I make cut, then it will form a small rectangle at point x comma y. The area of the dimension of the rectangle is delta x by delta y at point x comma y. If that small rectangle go up and it hits this 3D shape, it hits this 3D shape, then there will be small surface area it will map. Surface area it will map. That's small area. The surface area of that smallest surface area is nothing but cross product of PP1 and PP2. There is no hypothesis we are making. This is xz plane PP1. This is yz plane PP2. At any moment, this is the surface area. At any moment, this is the surface area. If I take P exactly on top, then xz plane, it will be like this because it is tangential. At yz plane, it will be like this. If delta x and delta y tend to 0, it will be tangential. The surface it will be flat. If I take here P here, then one will be like this in xz plane and one will be in yz plane, something like this. This will be the surface area. Here the surface area will be like this. Surface area will change. Surface area will be like this, tangential surface everywhere if I do cross product of PP1 and PP2. Let's do cross product of PP1 and PP2. Many people would find this very logical. So P1 is delta xi plus fx plus delta x comma y minus fxyk. P2 is PP2 vector is delta yj plus fx comma y plus delta y minus fxyk. If I do cross product of these two, then whatever delta x delta y rectangle I have in xy plane, that rectangle is going up and it is mapping to a surface region. Here, that surface region area I would get. And direction of the surface is surface is direction, right? Here's top surface direction is like this. Here surface area is direction. If this is the surface area everywhere, that is tangential surface, it has a direction. Like here everywhere direction is changing. Here surface area is like this. If this is the surface area, then its direction is like this. If this is the surface area here, then direction is like this. So direction is changing. Okay, anyway, I can take cross product of PP1 and PP2. So PP1 cross PP2. This is what is the surface area vector. This is called surface area. This proof is not there anywhere else. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Anyway, now we are in a mode of calculating the surface area. We got the surface vector. P1 vector cross P2 vector is the surface vector. In that case, let's calculate the cross product of these two. Okay, I believe whatever it comes, let's go ahead. Now PP1 cross PP2. Now whatever is there, I can divide it by delta x, delta y and multiply it with delta x, delta y. General terminology. Right? Then it will become PP1 by delta x cross PP2 by delta y as per the simple mathematics. Delta x, delta y in numerator. What is PP1? Delta x plus fx plus delta x comma y minus fxy k by delta x. Cross product delta yj plus fx comma y plus delta y minus fxy k divided by delta y. First one will become I plus dfxy by dx, because dfxy by dx is fx plus delta x comma y minus fxy by delta x. First principle of this is partial derivative. So it becomes I plus dfxy by dxk cross product j plus dfxy by dyk, because delta y by delta y, that becomes j1. If I calculate of these two cross product, it becomes minus dfxy by dxi minus dfxy by dyj plus k. This is the called surface area vector, new vector came into delta x delta y. Now this is the exactly surface area. Now this surface area vector I got. Now the vectors, what is your surface area vector? dfxy by dx minus dfxy by dxi minus dfxy by dyj plus k. If you take care of minus, then exact surface area direction. What is surface area direction? Here it is like this. 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 So here if it is like this, so if I take x comma y 0 0, at that moment the vector surface area is around k only. True, right? Minus dfxy by dx I minus dfxy by dy j plus k. At origin, if I go on top, then there is no slope here in xz plane also, in yz plane also. So dfxy by dx is 0 here, dfxy by dy is 0. So only surface area vector is k. This is what we are saying. Okay, if I take here, then it is only along I direction. So if dfxy by dy dfxy by dy is 0, here only x here at this point, if I'm calculating, if I take xz plane, if I if I take this here, then it will come at xz plane only, where y is constant. In that sense, then dfxy by dy is 0, where dfxy by dx is infinite, because little bit change will change z drastically. So infinite minus infinite I, okay, minus infinite I dfx plus k means it will be in I direction only. Okay, I am saying like this, someone can calculate. Or here, if I take here, it will be completely in j direction, where dfxy by dx is 0, something like that. Now if what are these fundamental? This fundamental is for delta x delta y reason. You remember that this, if I map it on xy plane, it forms a circle, and in the circle, it forms a circle. In the circle, I took any point x comma y. From there, there is a small rectangle. I made delta x delta y. That rectangle go and map here. For that small area region, that area is magnitude of this vector, that is minus dfxy by dx minus I minus dfxy by dyj plus k. Okay, if I calculate the magnitude of this vector into delta x delta y, if I calculate full magnitude of this, this transform into minus delta x delta y dfxy by dxi minus delta x delta y dfxy by dyj plus d delta x delta yk. If I calculate the magnitude of this vector, that a small surface area it will give. Now I can add all the small all, and it becomes full surface area. So delta x delta y, if I call that a small region I had taken here as ith small region, because it forms a circle. Inside circle, at every x comma y, I can make a small delta x delta y. Like that, I can make 1 billion. So this is ith component, and I have to add completely. If I add completely, then it will transform into integral calculus as per the modern way. If that is the case, then magnitude of dfx minus dfxy by dxi minus dfxy by dyj plus k, whatever the magnitude is, then delta x delta y, the full summation if I make for all the sub-rectangles, become dx dy. Integration will come where x is lower limit to higher limit, y is lower limit to higher limit. What is lower limit and higher limit? That is a circular region on xy plane. There is a circular region on xy plane. For that, lower limit to higher limit, y lower limit to higher limit. X is minus a to a if the radius of the sphere is a, whereas y is minus a square root of a square minus x square to plus a square root of a square minus x square. Because it is a circular region, they should be independent of each other, but that is not the case. Now, if that is the case, then full resolves into x is minus a to a, y is minus a square root of a square minus x square to square root of a square minus x square, because it's a circle with radius a here also, and that is x square plus y square equal to a square. And then dfxy by dx. Now, what is fxy? X square plus y square plus z square equal to a square, that is a sphere formula. Then fxy, that is z, z is equal to square root of a square minus x square minus y square. Dfxy by dx is minus x by square root of a square minus x square minus y square. Minus dfxy by dx whole square minus dfxy by dy whole square plus 1 square root. If someone does this, then it becomes x square by a square minus x square minus y square plus y square by a square minus x square minus y square plus 1 square root. That is a by square root of a square minus x square minus y square dx dy. Okay, we have demonstrated it very well. Someone can typically convert into polar coordinate system, but I would do directly. If I do it directly, then consider y equal to a square root of a square minus x square cos theta. Simple. Where y equal to square root of a square minus x square cos theta, where x is constant at this point. Then dy equal to square root of a square minus x square minus sine theta d theta. Now I can substitute there for the dy. Now dy is square root of a square minus x square minus sine theta d theta. And here a by square root of a square minus x square. Now in y term I'll replace it with a square root of a square minus x square cos theta. If I take it, then a by square root of a square minus x square into square root of 1 minus cos square theta into square root of a square minus x square minus sine theta d theta. Dx I am not considering right now. Now a I can keep outside numerator. Now denominator is square root of a square minus x square into sine theta. Numerator is square root of a square minus x square minus sine theta. Full gone. Minus remain, minus a I can keep outside, d theta integration is theta. D theta integration is theta. Now we have y equal to square root of a square minus x square cos theta, y equal to. In that case, theta equal to cos inverse y by square root of a square minus x square. That is theta. Now I have y is minus square root of a square minus x square to square root of a square minus x square. If I replace y with lower limit minus square root of a square minus x square cos inverse minus 1 pi 0 pi to 0 d theta means minus pi, and minus is outside and a is outside, pi a. Now integration of dx minus a to a 2a 2 pi a square is the surface area of the top hemisphere, because we did in Cartesian coordinate system and we took care of the top hemisphere. So surface area is 4 pi a square. So this is model I thought of covering the other way also, that is the velocity vector, and but this much is all right. So the surface area through the modern way, delta x tends to 0, delta y tends to 0, and so many are divided into so many sections, and then calculating the net surface area. First calculate the surface area of the smaller region and calculate for all the smaller region and add it. In that case, it is 4 pi a square is the surface area of the sphere through the model. This we proceeded from calculating the curve length through vector. So main idea here is introducing vector in the calculus. So through vector only. So first calculate the vector, two vector, cross it, get the surface area, then add all the surface area. Simple, right? And this is the modern way, delta x, delta y tends to 0. We will see other, I thought covering today. We will see other methodology also. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610. is the telephone number, plus 91 is the India country code.